Alright, let's dive into the Search Processing Language, or SPL, which is the query language used to interact with and extract data from Splunk. And with SPL, we can perform various tasks like searching, filtering, or transforming and analyzing the data stored in our indexes. And although SPL has evolved over time, some portions of its syntax should be familiar with us since it was originally based on the Unix pipeline in SQL. And so it's important to understand that we don't need to become masters of SPL specifically. And while SPL and Splunk is powerful and widely used, it's not the only SIM search syntax out there, and you might end up using a different SIM solution in the field. For example, the Elastic Stack uses the Kibana query language, or KQL, which has a slightly different syntax. And so what we really want to take away here is the general methodology of how to search for particular events, and what fields can we search by, and what logic or conditions can we use to pull back the information we need to correlate data. And so let's recall from the previous lesson, the most simple way of filtering using SPL is just by entering keywords. For example, if we wanted to pull back any events in our entire Splunk instance that match the word failed, well, we can just use the failed keyword. And so in our search bar here, again, I'm just going to specify the index of sample index to make sure we're looking at the events within the log that we imported. And from here, again, I can just type in the word failed. And again, if you're not seeing anything come back, make sure your time range selector here is set to all time. Or, as best practice, to narrow down the timeline that we're searching from, well, we know that our sample log events that we created match the timestamp of July 20th, 2024. And so we can update our time range selector to that date only. And so to do that, I'm just going to go down to date range and change this to between. And then I'm just going to set the parameters here to July 20th, 2024, all the way to July 21st, 2024, and just hit apply. Okay, great. So we can pull back any events that contain the word failed. But we're not being field specific here, at least not yet. In this case, we're basically just searching through the entire raw event for any instances of the word failed. But we'll get to that in a second. We can also select exact phrases or strings using quotes. And so instead of failed here, I can search for something like JDoe, and then with a comma, just add in login, because that's going to match exactly with this specific string here within this raw event. And so if I just hit enter, well, you can see we're pulling back any events where we have this actual sequence of JDoe with a comma and then login. And this is not the best example, but say if I had a string or phrase with spaces in it, well, we could wrap it in quotes to ensure that we capture the whole thing in our query, and not accidentally separate them out as individual phrases. Because, for example, without quotes, well, I could do a search for JDoe with a space and then log in. And so Splunk is treating these as two separate keywords here. And we can't see it, but it's actually injecting an AND here to search for both JDoe and the login keyword. And so if we run this, we're going to get the exact same results. However, I can change this to OR to search for anything related to JDoe or the word login. And so in this case, we don't have JDoe in the log, but we do have login. And so that's why we're pulling this back. Same with this one and this one. And so we're kind of jumping ahead a bit, but we'll talk about Boolean operators shortly. And so we can also introduce the wildcard character, or the asterisk. And this will allow us to cast a wider net, and will allow us to match more terms than just, say, a hard-coded failed keyword. And so, for example, I can change our query here to read fail with an asterisk after it. And this will match any event containing the word fail, or failure, or failed, and more. And so you can see this wildcard is going to match whatever string we give it, plus any additional characters after it, or wherever we put the wildcard. For example, we can put a wildcard at the beginning of a string, like this. And then add numbers like 004. And in this case, we're not going to get any results, but this could match codes like 1004, or 2004, and 3004, and so on. Or we can put it in between a word. And so, for example, instead of login, well, we can change the I here to an asterisk, or a wildcard. And this is going to match things like login or log on, respectively. What we could do in our case is use a wildcard to match the different minutes within our timestamps. And so you can see all of the different timestamps here are using the 12th hour. And so what I could do is enter 12 with a colon, put a wildcard with a colon, and then 2 zeros. And this is going to pull back all of those events just with the minute changed. And so again, this isn't the best example, but it is kind of how we can start using wildcards in between different keywords. And it's also important to note that our search terms here are not case sensitive. And so I can search for failed, or I can search for failed with, all caps. Or I can just put random caps throughout the word, and it's all going to match, as you can see here. Now, it's important to note that it's great that we can search based off of strings or keywords, and often it comes in handy. But the real power of SPL comes with using search fields and search field operators. And so rather than just searching for freeform text throughout the raw logs, well, we can actually use the extracted fields to our advantage and use these as key value pairs within our search queries. And this makes it a lot more powerful because we can search and filter based off specific fields or columns, and we can use comparative operators to construct our query in just the way that we want to. And so let's get a slightly more interesting log file ingested to give us more filtering options to work with. And so let's head over to the settings option here in the Splunk bar and click on add data. And from here, let's scroll down to the bottom again and click on upload. Then let's select the Apache access log file that we used earlier in this section. And so if you recall, that's going to be under the sim folder, under log analysis, and then it's titled access.log. And so with that selected, I'll just hit next. And by default, we can see that Splunk was automatically able to identify this as the combined log format, or CLF. And so I'll just hit next here, that all looks good. And I'm going to create a new index here, and I'm just going to call it http_sample. And just hit save, and review, and just hit submit. Alright, so now let's return to the search and reporting app from the Splunk bar. And so the first and simplest search field, or key value pair for us to search through, is the highest level field, or the index itself, which is actually what we've been doing so far. And so in our Splunk search, we can explicitly select the index that we want to search through. And it's possible to use a wildcard value, if I just do index equal wildcard, or an asterisk, but typically it's best practice for us to limit our search as early in the process as possible. And so to search in this kind of way with a field and value, again, we just need to provide the field name, and then with the equal sign, we can select the value. And so within quotes here, I'm just going to select http_sample, and just hit enter. And so again, we're not pulling anything back, and so what we need to do is adjust our time range. And so for this example scenario, again, let's set the time range to all time and run the query. And in doing so, we start to pull back all 3,000 events from our log file. And just out of curiosity, well, let's click on the Patterns tab again, now that we have more events to work with. And interesting, notice how Splunk is able to identify the pattern of the Hydra user agent making a large number of GET and POST requests. And so already we're able to use Splunk to identify interesting patterns about our data. Alright, so I'm just going to go back to events, and let's work with some more comparison operators within our field values. And so under the interesting events section here, well, you can see we have a number of individual fields extracted from our Apache log. And so we have a number of date fields, we have an interesting file field here, we have the HTTP method, the refer, the status code, and some information about the URI and the URI path, and the user agent as well. And so let's click on the file field here. And in doing so, we can get a list of all of the top values that were extracted. And so we can see that Splunk is actually going into the request string within the log and pulling out the actual file from the web page that was requested or posted to. Well, not the actual file, but the name of the file that was accessed. So in this case, login.php or admin.php. And so, for example, let's click on our top value here of login.php. And in doing that, you can see that this was automatically added to our search query in the form of a field value pair. And so this is the same syntax that we use to define our index, right? And so we have file equals, and within quotes, we have login.php. Which we could have typed this out ourselves, but it's interesting to see how we can actually just click on fields to add them to our search. And so we have this equal operator here, meaning that the file field needs to equal this exact string of login.php. However, we can reverse this to exclude any records that match this value as well by introducing the not equals operator. And to do that, we can simply prepend an exclamation mark in front of our equal sign. And so if I run this, well, now we're only matching 160 events. And if we open up that file field again, well, this time we can find no references of login.php since it's being excluded from the results. And we have other operators as well, like greater than. And so to demonstrate this, let's change our query to look at HTTP response codes. And specifically, that's going to fall under the status field. And so under top values, we can see different status codes like 200 or 302 or 404. And so I'm going to scroll up here and modify our search query. In this case, I'll pull back any events that match the status code that's equal to 200. And so this is pulling back any 200 or successful event codes. And if you want a reference to what these status codes mean, well, I'll put a link to the Mozilla documentation below. Now, let's say we wanted to pull back any response codes that were over or greater than the number 400. And so this will include any client error responses which map to 400 to 499, or any server error responses as well which map to 500 to 599. And so to do this, instead of the equal sign, well, I can just add the greater than symbol. And so I'll run the updated query. And now if we look at the status field, well, you can see we're only pulling back records with the event code higher than 200. And so we have a 302 and a 404, but not 200 or anything below that. And we also have the greater than or equal. And so instead of 200 here, well, what if I choose 404? Well, we're not going to pull back any records because we don't have anything matching a status code higher than 404. However, we do have records matching 404 exactly. And so I can edit this query to use the greater than or equal to comparison operator. And to do that, I'm just going to do the greater than sign followed by an equal sign. And now if I run the query, well, we're going to pull back those events that are matching the 404 event codes. And obviously, along with greater than or greater than equal to, we also have less than or less than and equal to, which is pretty self-explanatory in the context of what we just covered, so I don't think I need to explicitly cover that. And now, secondly, we also have what are referred to as Boolean operators, and these allow us to combine multiple search conditions and increase the precision and relevance of our search results. And so I guess the default operator is going to be AND, and that's because the AND operator is automatically applied when we have multiple conditions that are next to each other, like in our current query here. You can see first we're specifying the index field, and then after that we're specifying the status field. And so between these two statements is actually a hidden AND operator here. And so if I run this, we're going to get the same 8 events returned. And so the AND operator basically just combines the two statements together to return all of the events where we match this value from the index field and this value from the status field. Now, we can also use the OR operator. For example, I can change our query to either pull back GET or POST requests from the logs. And I can do that using the method field. And so instead of status here, I'm going to change this to method equal GET or method equal POST. And if I run this, well, we're going to pull back a good chunk of events since they mostly match one or two of these values. However, I can also add the NOT operator to explicitly ignore these events. And so to modify our search here, I can change this to be AND NOT. And now if we run this, well, we still get a lot of events. And so that's kind of odd, right? If we take a look at the method field, interesting. We can see that the post value is still there as the highest value. So what gives, right? Well, this is due to the order of evaluation of our Boolean operators. And so our search string here might not behave as you expect due to the way that Boolean operators and their precedents work in SPL. And so the order of evaluation is the NOT clauses, and then the OR clauses, and lastly the AND clauses. And so due to this operator precedence, the original query only negates the GET value here, because the OR operator has to be evaluated separately, and it gets included regardless of the negation condition here. And so if our goal is to exclude both GET and POST requests here using NOT, well, we can change our query to group them together with parentheses. And parentheses can be used to alter this order of operation and ensure that specific conditions are evaluated first, or in this case, evaluated together. And so I can just put parentheses around the method get or the method post. And now, if we run this, well, we're cutting down the results quite significantly. And if we go down to the method field, well, you can see we're only pulling back those other interesting values like options, or prop find, or head. And so I also wanted to point out that we can still use wildcards in our search fields as well. And if we look at the client IP field, well, you can see it refers to the actual IP addresses that were used to make the connection. And so we get a very quick and useful list here of the top talkers, or the top IP addresses that were found within the log file. And so we don't need to go around cutting and extracting out fields and sorting them to find the unique values. Splunk does all of this aggregation for us automatically. And so what if we only wanted to pull back the IP addresses that matches a specific subnet? Or, just for another example, only pulling back IP addresses that start with the number 100. Well, with wildcards, this is quite simple. And so I just need to specify the client IP field and set that to equal 100. And then if we want to match the formatting, we can do a dot with a wildcard, with a dot and another wildcard, and finally, dot wildcard. And if I run this, well, in this case, we're only pulling back 3 records that match that wildcard. And if I take a look at the client IP field, again, we can see why. They all start with 100. Lastly, remember that our timeline and time range is crucial for focusing on specific search results and understanding the order of what happened and when. And so when we pull back events, we can specify keywords like earliest and latest to manipulate our time range rather than using the time range picker manually. And so first, we have the earliest keyword. And this specifies the start of the time range for our search. And so it defines the earliest time from which we want to include events from. And we have a lot of options when it comes to the actual value of earliest here. And so we can use relative time modifiers, like we can set this to equal -1 day. And this will set our earliest value here to 1 day ago. Or we can use 1W here for 1 week, or -1H for 1 hour. Or we can use absolute times. And so I can specify something in quotes like 07 for July, 17th for the day, and then 2024. And then with a colon, we can specify the time, 00:00:00 for the start of the day. And you can see because this absolute value matches, well, we are pulling back the events. We also have the latest keyword as well, which kind of similar to earliest, but I guess opposite, specifies the end of the time range for a search. And so we can define the most recent time up to which we want to include events from. And again, similar to earliest, well, we can use relative time as well. And so I can set this to equal now to specify the current time. And so if I run this, we should get the same results because we're searching from this specific date all the way up to now. Or we can use absolute time as well. And so again, within quotes, I can search for 07, 17, 2024, and let's pick a specific time of 18 for 6 o'clock, 48 with a colon 20. And if I run this, we should actually cut our results. And so again, you can see we're only pulling back 76 events because we selected a specific latest time here, which actually cuts through our actual log file. All right, and so that was a good hands-on look into the basics or the fundamentals of understanding the search processing language within Splunk. And I'll also add here, as best practice, we want to use our filter commands or search fields as early as possible in our search to limit the number of events that Splunk has to index through, which helps make any future manipulations of the data that we need to do return much faster. And so there are a number of other super useful filters and transformative commands that we're going to cover in the next lesson that are really going to level up our searching capabilities and the value of data that we can pull back during investigations. And so I'll see you in the next lesson.